first of all, putting up at the top of our page that we are doing lesson 5.3 notes 4. This is actually our 4th set of notes in this lesson. And we're going to be on page 346 of our books doing the check it out. So, you know, when you look in your notes, it'd be nice to be like, where did this come from? Because I'm going to guess you're not going to want to write the whole problem out in your notes. And we're going to do, it's in the middle of the page, we're going to do problem number 4. So, do a quick read through that problem and see if you can, you know, identify what are the unknowns that we're going to give variables to. Okay, anybody have any ideas for us? Any suggestions? And you're gonna, you get to pick the variable, and you get to tell us what it's going to represent. So, what's one of the variables? Cody?
Do you want me to just only say what X and Y represents? Or?
Right, I don't want an equation yet.
Okay. X represents the number of lilies sold.
Okay, X is, I'll let you abbreviate here, number of lilies sold.
It's not sold. She's buying them.
So bought?
Or bought.
Oh yeah, that's kind of good to know for buying or selling, okay. So, number of lilies bought is X, and what's Y going to be then?
Number of lilies bought. Or number of tulips bought.
Okay, so see if there's 2 kinds of lilies, now we're going to have to be even more specific about the lilies. So they're
Tulips.
Tulips, okay, is number of tulips bought. Okay, this serves a couple of purposes. It helps us make sure in the equations when we're setting them up, we put them with the right numbers. We're working with the numbers properly with them, and it does serve another purpose. In the end, when we're all done getting those values, we now can say, oh, when I get 10 for X, I can say in my sentence answer, who is this person, by the way? Who's working in it? Is her name related? Sally. Sally bought, you know, maybe 10 lilies or whatever we find out. You can look up there, it's that easy. Okay, go ahead and set up your own system of equations that you think would work for this one, and then we'll compare. Set up a system of equations with all of us having X being representing the number of lilies that are going to be bought, and Y being the number of tulips bought. Cody has no more speaking privileges. Aurora has no more speaking privileges. But the rest of you do. So who wants to offer up one of the equations that should work in this system? Abby?
$1.25 X plus 90 cents Y equals $14.85.
Is that $14.80?
Yeah, $14.
Okay. So here's what without me even looking in my book and looking at the problem right now, here's what this tells me. Every lily costs $1.25. Every tulip costs 90 cents. Altogether, she spent $14.85. Okay, then this seems like a good one, doesn't it? Okay, the other one. Noah?
X plus Y equals 13.
Okay, here's what this one tells me. The number of lilies bought altogether plus the number of tulips bought altogether, add those together, there were 13 flowers bought. Is that true? Okay, then we have our system. here we are. There's our system of equations. Now, before we even decide to rename these, I have a suggestion for us. That one that has decimals in it, does it have to be dollars? Could it be cents? Or in other words, could we change it to pennies?
Yes.
What could we do to change
Move
that?
the
This,
decimal over 2 times to the right.
so we would multiply each of them by 100 is really what's happening because there's 100 pennies in a dollar, right? So we're moving the penny, the dollar, we're multiplying by 100 to change them to pennies, and now we really could rewrite this. 125 pennies for every lily, plus 90 pennies for every tulip. Altogether, I gave them 1,485 pennies. That's probably how we would really do it, but now we don't have to deal with decimals, okay? So we can just rename that, and now we have x plus y still. We don't need to rename this one, do we? Okay. Now, we're going to run through the process that we always need to run through from here on out. We are doing lesson 5.3, and lots of things have happened in 5.3. Our first question we're going to ask ourselves, well, I guess we have to do one more thing here that we haven't done that I don't know if you're doing or not, but A equals B equals A equals B equals. Okay, go ahead and get those identified. So you run through this gamut of questions because you don't want to work any harder than you have to. At least I don't. So the first question is, are either the A's or the B's opposites of each other? No. Second question is, are either the A's the same or the B's the same? No. Could I just create opposites by multiplying, renaming only one of them?
Yes.
Yeah.
Okay, well, what's your suggestion then?
We take the second equation and multiply it by negative 90 to get.
Opposite B's?
Yep.
Okay, so we can multiply the second equation by negative 90 to get opposite B's. What's another option we have? Take the take the second equation times negative 125. So it kind of seems like we just want to rename the second one, don't we?
That'd be the easiest.
That would be the easiest, wouldn't it? Why rename both of them if we don't need to?
Because then we have to rename both of them.
Yeah, and then we'd have to find a multiplier that, yeah, we just complicate the matter. So which one should we do? Should we do the 90 because it's a little bit smaller numbers? Okay, so let's take the second equation and let's multiply it by 90. Or what? Negative 90 it has to be, doesn't it? So the second equation is going to get renamed multiplying both sides by 90. Ten times 13 is 130. But I went 13 too many, so that's 117, and then I've got a 0 there, so I think that will be 1,170, and it'll be negative. You check it out. Calculator. Is it negative 1,170? Yeah, I could be wrong. I'm right? Yep. Ooh, awesome. Okay, negative 1,170. Don't you wish you could do that? Won't you receive your system? You could. Okay, so now, what are we going to do with that? What are we going to do with that?
We're going to add it to the first equation.
Add it to the first one. Okay, negative 90x plus negative 90y equals negative 1,170. We're going to add it to the other one, which is a 125x plus 90y equals 1,485. Okay, it appears we're going to solve for the number of lilies first, aren't we? Okay, let's figure out how many lilies there are. Go. see, 10 times 35 would be 350, and if you took 35 away from 350, that would be 315. That must be 9. Don't you wish you were a senior citizen?
No.
Is that what you get? With your calculators, you silly people. Did you get 9? Okay, those are, just for, so we could say this is going to be important, but of course we're going to write our final answer as a sentence, and these are 9 what? Lilies, this is just in case you want to add that part, just to remind yourself. Okay. Go get the number of tulips now. I hope you're not a crazy person. They're going to work too hard. Anybody get y = 4? Hope you didn't work very hard. Use this equation. You guys are so smart. Okay, then the final sentence answer will be, what's this girl's name again? Sally. That'd be a good place to start. Sally bought, sold, gave away, bought 9 lilies and 4 tulips. End of sentence. It is high time for me to start taking away half points for a bad sentence. No punctuation at the end of them. I wonder how many purple colored punctuation marks I've made on papers for people. Okay, are you ready to do homework? Taking out all your other 5.3 notes to help you. And along with it, you are doing 8 problems, 2 of which are application problems like this, where you have to set up your own system, starting with describing variables, using them in your equations, solving, ending with a sentence answer.